Hello students, welcome to Sreenath. In this video, we are going to learn the first chapter in class 7th Maths. Okay, my name is Karthik Nunne. We are creating all subjects from class 6 to class 8. So please subscribe our channel. Also follow us on Instagram and join our Telegram channel. Links in the description below. Okay, let's begin this video. In this video, we are going to learn a new chapter. It is the first chapter in the class 7th physics, that is integers. What it is? Integers. In this chapter we are having total 7 topics. Okay, total 7 topics and some exercises. In this video we are going to learn what are those 7 topics only. To understand these 7 topics, we will touch we will do small problems, but the problems in the exercises will not be solved in this video. If you want those problems in the exercises to be solved, please comment below. If we get sufficient number of comments from the students, then we will surely upload the videos on exercises. Full exercises will be solved. So without wasting time, we are going to start the session. Okay, now in the beginning we are going to have an overview of what are those all 7 topics. After that we will discuss each topic in detail. Okay, the first topic is introduction. In the introduction, what we have learned in your previous class, which is in 6th class, we will go to discuss. It does not a big matter. The second topic is recall. We are recall, which means we will recall what are the topics or we will recall what we have learned in the previous class, that is in the 6th class, like that. So all the topics or all the things we are going to learn in the second topic is nothing but we are just recalling, we are just recapping our previous knowledge. Then we came into the third topic, which is properties of addition and subtraction of integers. What are the properties of integers when we add two integers or when we subtract two integers? How their properties will be? We will see what are those properties. Basically, properties we have are closure property, and commutative property, associative property, additive identity. That's it. After that we are going to into the fourth topic, that is multiplication of integers. Till now we learned what are integers and how integers will be added and how integers will be subtracted and what are the properties of integers under addition and subtraction. Now we will study about, or we will know about how we can multiply integers. What happened when a positive integer is multiplied with a positive integer, a positive integer is multiplied with a negative integer, and vice versa of all those situations. After that we will enter into the fifth topic, which is properties of multiplication of integers. What we have learned in the previous topic about how we will multiply integers. Now what are the properties when integers are multiplied? We'll again see the closure property, commutative property, and multiplication by zero, multiplication by identity, associative property, distributive property. Okay, after that we will discuss how we will divide division, how we will divide integers. Okay, how can we will divide integers. After that, what is our seventh and last and most important topic is properties of division of integers. What are the properties when we divide integers? So we have completed the overview of all the chapter. Now we are going to learn each topic in detail. Okay, now come on friends, please like the video and please join with us. Now we are going to start our session. We are going to start our first topic, that is which is nothing but introduction. What is the introduction means? What we have learned in the previous class, we have learned about the numbers, which are basically about natural numbers, which is starting from 1 to infinity, and the whole numbers which are starting from 0 and so on goes to infinity. Okay, we have learnt about whole numbers and integers in class 6, and we have learnt about integers also. Z, we represent integers Z by Z in our 8th class. How integers are they? Integers are from negative infinity to 0 and 0 to positive infinity. Okay, we have learned about the integers in the previous class, which means what are integers, we have learned about it. Now that is all in the first topic. Okay, now what will we do? Now we will do we will do much on integers. Okay, this is the first topic which is completed. Now we are entering into the second topic. What is the second topic? Which is means recall. What now we are doing? We are just recalling our previous knowledge. Okay, how can we represent integers on a number line like this? Basically, the number line, the center of the number line is 0, and to right to the number line we will place 1, 2, 3 and so on, and to the left of the 0 we will place -1, -2, -3 and so on. So this is the number line. In this number line we are representing the integers. These are the positive integers, these are the negative integers. Okay, in this way we can indicate integers on number line. Okay, and this number line is in ascending order. Okay, from our previous knowledge, what are our conclusions? We have done addition and subtraction of integers in our previous class. What we have done in our previous class, we have studied what are integers and what are positive and negative integers, and we have studied how to add and subtract integers. From those previous knowledge, what we have learned, that is add a positive integer, we move to the right. When you add a positive integer to a number or a point in number line, we'll move to the right. When you add a negative integer, then we will move left in the number line. When you subtract a positive integer, when we will move to the left. When we subtract a negative integer, we will move to the right. These are the conclusions we have got in the previous class. Okay, which is means in your 6th class we have got all these information, all this knowledge from the previous class, 6th class study. Okay, now what we are going to learn is about we will recall all what we have learned in the previous class. Okay, after that we have to do this exercise to strengthen our concepts which we have learned in the class 6. After that we are entering into the third topic, which is properties of addition and subtraction of integers. Okay, what are the properties? Basically we have closure property and distributive property, like that we have so many properties. So what we have to do? We have to do properties on addition, properties on addition, properties on subtraction. Okay, now we will start with properties on addition. The first property is closure property. What it is? Closure property. What closure property tells us? Basically, if suppose if you add here, what the example they have given here, they given 17 plus 24, then what is the resultant? When we add 17 and 25, we will get 41. Basically we have studied closure property regarding whole numbers. 17 is a whole number, 24 is a whole number. If you add both whole numbers, the resultant 41, which is also a whole number. So hence closure property is satisfied. So what is meant by closure property means, if you add any two numbers, any two integers or any two whole numbers, then the resultant whatever we get is must also that integer, then we will say that closure property is satisfied. If you add two integers, then we will get another integer, then we will call it as closure property is satisfied. Basically for whole numbers we have learned in the previous class, when we add two whole numbers, then the resultant is also whole number, then we called closure property is satisfied by whole numbers under addition. Here here we are considering integers. When we add two integers, if the resultant are also integer, then we will say that closure property is satisfied. Basically here 17 plus 23, 17 is an integer, 23 is integer. While adding we get 40 is also integer. So closure property is satisfied. Here there are some negative integers. There are -10 plus 3. What is the resultant? -7, which is also an integer. So this is an integer, this is an integer. When we add two integers, we get the result which is also an integer. Hence closure property is satisfied under addition. So integers are closed under addition. We can call it in this way also. Integers are closed under addition. So what is the basic formula for closure property? Closure property means for any two integers A and B, regarding closure property for integers under addition. For any two integers a and b are two integers, a and b are maybe any integer, positive integer or negative integer, like 1 2 3 4 or -1 -2 -5, like that. Then if we add both of them, a plus b is also again an integer, then we call that closure then integers are closed under addition, or closure property is satisfied by integers under addition. This is about closure property under addition. Then what is about closure property under subtraction? Basically, closure property under addition is similar to closure property under subtraction also. What is the basic thing we are changing? Subtraction. What is the basic thing which we are changing in these two situations? Means we are just adding two integers, we are subtracting two integers. What's the final conclusion we have to get? The final conclusion is the final result must be also the integer. So that we can set that closure property is satisfied by integers. Closure property is satisfied by integers under addition, closure property is satisfied integers under subtraction. Okay, that is about closure property under addition and subtraction. Here closure property under subtraction, what happens? 7 minus 2, it is -2, which is also an integer. So with 7 and 9 are integers, -2 is also the resultant of two integers is also integer. So we call that closure property is satisfied under subtraction. If you take this also, -18 minus of -18, which means it gives to 0. 0 is also an integer. So these two are the integers and the resultant is also integer. So what happened finally? Closure property is satisfied under subtraction. Here if a and b are two integers, then a and minus b is also integer. If a and b may be 1 2 3 or any integer, a and b are any integers, we can take from -infinity to +infinity. If you subtract them, then we will get another if you get another integer, then we call it as closure property satisfied for integers under subtraction. Okay, now we have moved into the another property, that is commutative property. What is commutative property? Basically, take this example, commutative property. Okay, what this property tells us. Take this example, 3 plus 5, add, what is the resultant? Now add 5 plus 3, what is the resultant? Basically 3 plus 5 is equal to 8, 5 plus 3 equal to 8. So what is the change in these two examples? In these two examples, right side term 8 is same, but the left side term 3 and 5 are also same, but their order is changed. In this 3 is added to 5, in this 5 is added to 3, in this 3 is added to 5, but the resultant is same. So when we take it generally, when a plus b equal to b plus a, we call that as commutative property, which means even though if you change the order of the digits, if you change the place of the digits, the resultant won't change. If you change the place of the digits, even though if you change the place of the digits, if the resultant is not changed, then we say that that integers satisfy commutative property. This is about commutative property. Okay, can you understand it? Yeah, if not, please feel free to comment below. Next, associative property. What is meant by associative property? Basically there are the integers -3, -2, -5. Okay, now what we have to do? Suppose the integers are -3, -2, -5. Now what we will do like this: -5 plus big bracket -3 plus -2. Okay, what is the answer? Now again, -5 plus -3 whole bracket, then -2. Then what is the answer? In this case, -5 plus, what will we do in this case? -5 plus -3 -2, which means -5. The answer is 0. Sorry, -5 -10. Okay, -5 -3, which means -8. Again plus into -2, which is also -10. So what happened here? the answer is same. But what is the change in this and this? What is the change in this equation and this equation? Basically, what is the change? The change is in the big brackets. If you take a is equal to -5 and b equal to -3 and c equal to -2, what we have get in the final answer? A plus b plus c is equal to what here? What is second? A plus b plus c. Okay, this is the conclusion we get. So this is called associative property. If we add a and b plus c at a time, and after adding b plus c, if we add it to a, you will get some result. And after that, if you add a plus b at a time and then you add c to the resultant, then if you get some resultant, if both the results are equal, then we say that it allows associative property, or it satisfies associative property. Okay, can you understand it? Can you understand it? Then if a plus b plus c is equal to a plus b plus c, then we call that it is associative property. You will not find any example for which the sums are different. Addition is associative for integers. Then what will you say? Addition is associative for integers. For us, for integers, addition is associative. It follows associative property. Okay, this is the associative property. Next, additive identity. Additive identity means what? Here -8 plus 0. What is the result? That is -8. Here 0 plus -37. What is the result? -37. Here 0 plus -8. What is the minus 0? Here 0 plus something is equal to -43. Then what might be the dash? It might be -43. Why? Because here when you add 0 to -8, the result is also -8. Here when you add -23 to 0, the result is also -23. Or here when we add 0 to -8, the result is -8. So if you want to add 0 to anything, the answer will be also anything. So for that reason, 0 plus of -43 equal to -43. So the above example shows that 0 is an additive identity. What it is? 0 is additive identity. Additive identity. Identity for integers. Why? If we add a plus 0, that is equal to a. If you add a to 0, that is also equal to a. If anything follows this rule, then we call it as additive identity. Basically here 0 is the additive identity. Why? Because means if you add anything to 0, the resultant will be the anything. Or if you add 0 to anything, the resultant will be the anything. So that's why here 0 is the additive identity. After that, we have completed the third topic. Now we have entered the fourth topic. What is the fourth topic? Means multiplication. What it is? Multiplication of integers. How we will multiply integers? Okay, basically the first topic is multiplication of a positive and a negative integer. The first topic is positive multiplied with negative integer. What it is? Negative integer. What happens? Basically there are so many examples here. Okay, suppose here there is example. We know that multiplication of a whole number is repeating addition. Multiplication is nothing but repeated addition. So for example, if you take like this, 5 plus 5 plus 5, which means if you take 5 as common, 1 plus 1 plus 1, 2. So 3 into 5. We have how many 5s here? 3 5s here. 3 5s here. So 5 3s are 15. So multiplication is nothing but repeated addition. If you repeatedly addition any number, then multiplying that number with how many times it is repeated gives the multiplication. Okay, if any number is repeating, the multiplication of that number with how many times it is repeating gives rise the multiplication of that number. Here 5 is repeating, so that number means 5 into how many times it is repeating. Here it is repeated 3 times, so into 3. So 5 into 3 or 3 into 5, that is gives the multiplication. 5 into 3 is the 15 answer. Basically in the same case, if you here -5 is repeated, it is added 3 times. So what we will get? We will get -5 into 3, which is nothing but -15 here. Okay, we will write minus 15 as 3 into minus 5. So next, similarly, if you add minus 4 5 times, 5 into minus 4, that gives you 5 times, the 5 into minus 4, that will gives you minus 20. If you observe here, 3 into minus 15, here there is multiplication, and there is one positive integer, one negative integer. Finally, we are getting the answer as integer. But when we add a positive integer with a negative integer, we are getting negative integer. When you multiplying positive integer, negative integer, we are getting negative integer. So finally, what we can conclude it here also, 5 into minus 4, it is a positive, it is the negative, we get negative integer. It is also, it is minus of 5 into 4, so minus 20. So finally, what we can conclude that, what we can say now, how multiplication will be happening. 3 into 5 gives rise to 15, 2 into 5 gives rise to 10, which is nothing but 15 minus 5. Next, 1 into 5 gives rise to 5, which is nothing but 10 minus 5. Next, 0 into 5, that is equal to 0, which is nothing but 5 minus 5. Next, what is meant by 1 minus 1 into 5, which is nothing but 0 minus 5. 0 thing but minus 5, minus 5. We can write minus 5 as 0 minus 5. Next, minus 2 into 5, which is nothing but minus 5 minus 0, that is minus 10. Minus 3 into 5, which is nothing but minus 10 minus 5, that is equal to minus 15. So following this order, in this case, what we have concluded that we thus find that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put as minus sign before the product. We thus get a negative integer. So what happened when positive integer is multiplied by negative integer? The resultant is negative. What it is? Negative. And what another thing we have to remember is the result is negative, and the result is the product of both numbers, like whole numbers. We have to multiply it like whole numbers only. We have to treat those numbers as whole numbers only, and we have to put negative sign before it, because we are multiplying positive integer with negative integer. By observing all this, we are getting that conclusion. Allow number minus sign before the product. Okay, now here in general, for any two positive integers a and b, suppose a and b are two positive integers, then we can say a into minus b is equal to minus a into b equal to minus of a cross b. So minus symbol stays there for a long time. Now what is the second condition? Second condition is multiplication of two negative integers. So negative multiply with negative. What happened when you multiply negative and negative? Basically, can you find the product of minus 3 into minus t? Before that, minus 4 into minus 3 into 4 gives rise to minus 12. In this way, you go minus 3 into 0, minus 3 into minus 1, minus 3 into minus 2. Then what we get? Minus 3 into minus 2 is nothing but minus into minus plus 6. So minus 3 into minus t equal to, that is 3 minus of minus 3, which is nothing but 6. So we can write 3 minus into minus plus 3, that is equal to 6. So observing this, what we have concluded finally, that when two negative integers are multiplied, the resultant is also positive. Okay, product of two negative integers is a positive integer. What happens when negative cross negative is multiplied? The result is a positive. What previously we have learned, positive into negative is negative. Okay, next. Okay, product of three or more negative integers. What happens when you product two or more three or more means 3 negative integers or 4 negative integers? Here we have multiplied 3 negative integers. What happened finally? Minus 4 into minus 3 into minus 2. Minus 4, first what we have to do? We have to multiply both these or these two first. After that we will multiply this with the product of this. So here first we have multiplied -4 and -3. -4 into -3, what happens? And into -2. -4 into -3, what happened previously? When you multiply two negative integers, then we will get a positive integer. So we will get a positive integer, and 4 into 3 is equal to, according to whole number multiplication, it is 12. Now what we are doing? We are doing multiplication of a positive integer and negative integer. What we have previously learned? We have learned when we multiply a positive integer with a negative integer, we will get a negative sign. We have to put a negative sign, and we have to do the normal whole number multiplication, which is 12 2s are 24 minus 24. So finally what we have concluded, that when we multiply three negative integers, we will getting as negative symbol. Now when we multiply four negative integers, what happened? Here see, -4 into -3, -3 into -2, -2 into -1. At first what will we do? We will multiply these two numbers. After that we will multiply these two numbers. Then we will multiply the result of these two numbers. -4 into -3. When you multiply two negative numbers, you will get a positive number, and the multiplication is as similar as the whole number multiplication. 4 into 3 gives rise to 12. Sorry, 4 3s are 24. That is 24. Okay, and we are multiplying negative into a negative. But here what they have do means, they have done in the different way, but we will do it in the simpler way. Okay, suppose -4 into -3 into -2 into -1. We are going to multiply all these four integers. So for that what we have done? We have done put brackets between these two and these two. First we will multiply these two, next we will multiply these two. So what is the product of these two? When we multiply two negative integers, we will get a positive integer from previous knowledge, and the multiplication is as the whole number multiplication. 4 3s are how much? 4 1s. 4 3s are how much? 4 3s are 12, and we are getting positive symbol here. Next what it is? We have to multiply this. When you multiply two negative numbers, we will get positive, and 2 into 1 is the 2. So now what we have to do? We have to multiply both these two positive integers. So no problem, when we multiply two positive numbers, it is just similar as the whole number multiplication. So 12 2s are 24. What happened? The answer is positive. What it is? Answer is positive. Answer is positive. So what we have observed, that when we multiply three negative integers, resultant is negative. When we multiply four negative integers, resultant is positive. So finally what we can concluded from the above products? We observed that the product of two negative integers is a positive integer. When we multiply two negative integers, we will get a positive integer. The product of three negative numbers is a negative integer. So when we multiply three negative integers, we will get a negative integer. But when we multiply four negative integers, we will get a positive integer. So from that what we have concluded, if the number of negative integers in a product is even if the number of negative integers in a product is even, then the product is a positive integer. Okay, what does it mean? Number of negative integers. In this case, how many negative integers are there? We are multiplying. Here we are multiplying three integers. Here we are multiplying three integers. 3 is an odd number. It is not even. So now we consider this case. In this case, how many negative integers we are multiplying? We are multiplying 4 in negative integers. 4 is an even number. Then what will happen? According to what is the conclusion we are getting is, if the number of negative integers in a product is even, here the number of negative integers is 4, which is even, then the product is a positive. Then what is the result means? Which is positive. Actually this is the result we are getting while multiplying four negative integers. So finally we have concluded, if the number of negative integers which in a product is even, then we will get a result positive. Then what happened if the number of negative integers is odd? If the number of negative integers in a product is odd, like in this case the number of negative integers are 3, which is an odd, then what is the resultant? Then the product is a negative integer, then the product of the result is also negative. So one thing, if the number of negative integers are even, then we will get positive. If the number of negative integers are odd, then we will get negative. This is of the product of 3 or more negative integers. What happened when two negative integers are added? Multiplication of two negative integers gives a positive integer. Name product of two negative integers is a positive. What happened when a positive is multiplied with negative? When positive is multiplied with negative, what happened? While multiplying a positive and a negative number, we multiply them as a whole number. We'll multiply them as a whole number and we put a minus sign. That's it, which means negative integer. So what we have learned? We have completed our fourth topic, which is nothing but multiplication of integers. How we will multiply integers? Basically, if we are multiplying positive integer with a negative integer, we have to do the whole multiplication as normal as whole numbers, and we have to put the negative symbol. So in the case of multiplying a positive integer with a negative integer, we will get negative integer. In the case of when two negative integers are multiplied, then we will get a positive integer. In the case of when three negative integers multiplied, we will get a negative integer. In the case of four negative integers are multiplied, we will get a positive integer. Finally, what we have concluded, that if the number of negative integers in a product is even, then result is positive integer. If the number of negative integers in a product is odd, then the result is a negative integer. This is the conclusion we have done in the fourth topic. Now we are going to discuss fifth topic. The fifth topic is properties of integers under multiplication. Properties of integers under multiplications. Okay, here closure under multiplication. What basically closure property tells? If we multiply or if you do any operation between two integers, then the resultant must be a integer. Then closure is satisfied. Basically, now here we are discussing closure under multiplication. Then what we have to do, and then what we have to do means, then if you take two integers, then those if you multiply those integers, then we will get some result. The result must be also be a integer. Then we say closure under multiplication is allowed, or closure under multiplication of integers is satisfied. Take some examples. Minus 20 into minus 5. Basically, minus 20 is a negative integer, minus 5 is an integer, which means both are integers, and we are multiplied. Finally, what we have get? We'll get 100, which is a positive integer. So product is also an integer. We multiplied with the integers, and we get the result as also integer. So from this, we can conclude that closure under multiplication is satisfied. Okay, or so that integers are closed under multiplication. We can read it as like this also. Integers are closed under multiplication. So what is the perfect definition is, if a cross b is an integer for all integers a and b. If a comma b means any integers belongs to integers. Integers means z, means a may be 1 2 3 or like that, b may be 1 2 3 or minus 1 like that. Then if we multiply a cross b, then we will get that also belongs to integer, which means a cross b is also anything like minus 1 minus 2 or minus 3. The resultant of a cross b is also like minus 1 minus 2 like that. Then we say that closure is satisfied, or integers are closed under multiplication. This is about closure property under multiplication. Now commutative of multiplication. What is meant by the commutative property? Before moving that, we will see the examples. Here 3 into minus 4, we have multiplied 3 into minus 4, that we get minus 12. Here minus 4 into 3, that is equal to minus 12. So the answer is same in these two conditions, but what is the RH is same in these two conditions, but the LH is different in these two conditions. What is the change in difference in the LHS? Means we just reversed the place of the digits, but the result is same. So finally what commutative law says means, if a cross b equal to b cross a, then we say that it is satisfied commutative law. If 3 into 2 is equal to 2 into, then we say that this commutative law is satisfied. This is for whole numbers. In the same way, if we are taken integers, for that reason it is a negative integer, it is a positive integer. So finally we get result which is also integer, and we interchanged these two digits and we have multiplied, and also in this case also we get the same result. So a cross b here and b cross a here, but the result is same, which means a cross b equal to b cross a. So commutative, which means the examples above examples suggest that multiplication is commutative for integers. What it is? Multiplication is commutative for integers. Now multiplication by 0. What happens? We will multiply any number with 0. Minus 3 into 0 is 0. 0 into minus 5 is 0. So what happened? Minus 5 into 0 is also 0. 0 into minus 6 also 0. Finally, what we have get that the product of a negative integer and 0 is 0. Product of a negative integer and 0 is a 0. Basically, product of positive integer into 0 is 0, which we know already because we have known in the whole numbers. But here the difference is we are in integers, we are having negative integers. So that's why the product of negative integer and integer is 0. In general, what will we write it as? A cross B. A belongs to any integer. It may be positive integer, it may be negative integer. Then that is equal to 0. Then 0 cross A, which is also equals to 0. Then we call that multiplication by 0 is satisfied. Then multiplicative identity. What is the multiplicative identity? Now what we have done? We have done some examples. Minus 3 into 1, which is minus 3. Minus 4 into 1, which is what? Which is minus 4. Minus 4. Here 3 into 1, what it is? 3. So in all examples, what we have done? We have multiplied integers with 1. The result is also that integer. So what we called, then we called one as multiplicative identity. We called one as multiplicative identity. What is the rule for multiplicative identity? Means a cross 1 is equal to 1 cross a, that is equal to a. Then we called one as multiplicative identity, which means if you multiply anything with 1, if you multiply anything with, or if you multiply 1 with anything, if the result is the anything, then we call that as a multiplicative identity. Here the multiplicative identity is 1. Here multiplication by 0. So these are, here 0 is called the additive identity. What we called here 0 is called the additive identity, but whereas 1 is the multiplicative identity for integers. Okay, for integers 0 1, 0 is additive identity. 1 is multiplicative identity, which means we get the same result. Multiplicative identity, we get the same 1. Okay, this is about multiplicative identity. Next, the property is associative for multiplication. What is meant by associative property? Means it is nothing but interchanging brackets. For example, take here minus 3 into minus 2 into minus 5, sorry, plus 5. We will multiply it in this in two different ways. First thing is minus 3 into minus 2. Okay, we have put the big bracket for these two integers, and next 5. Okay, in this case we have considered, we will first work on these two integers, and after we getting some product, we will multiply that product with this. In this way we will go on this mat in this process. Next process is, if you take bracket between the next two digits like that. Here we have left this singly and we have put a bracket for these two digits. Now what we will do, we will do operation of the 1 and 2 numbers which are in the brackets. After that we will get some product, we will multiply that product with this. What happens? Minus 3 into minus 5, which gives us 2 negative integers, gives to positive integers. So that is 6 into 5, which means 30. What happens? Minus 3 into minus 5 into 2, what happens? That is minus 25, which means minus 5 to 20. What happens? 2 negative integers becomes positive. 10 into 3, 30. So the result is same, but what we have to do, we have interchanged the brackets. We have to taken and changed the changed the consideration. So what finally you can say that A cross B cross C, here the brackets are between B and C, is equal to A cross B cross C. Here the brackets are between A and B. Then we will say that associative is hold for multiplication, or associative is satisfied by multiplication. Now distributive property. What is meant by distributive property? Here again another example. Here 16 cross 10 plus 2 is there. Okay, now what will we do? We will 16 into 10 plus 16 into 2. These are the two conditions. We will solve it. What happens? 16 into 10 plus 2 means 16 into 10 plus 2 is 12. Here 16 into 10 is 160 plus 16 2s are how much? 16 2s are 32. Finally, what is the answer? 160 plus 30 means 192. Okay, 192. 16 into 12 means 16 10s are 16 into 12 means 6 2s are 12. 2 1s are 2 plus 1 3 plus 1 6 are 6, 1 1s are 1. What is the result? 2, 6 plus 3, 9, 1. So what happened? This has the same result, but what is the difference? Here A cross B plus C, here A cross B plus A cross C. So but the result is same. In this case, we called it as the distributive property. Distributive property. What this property tells us? A cross B plus C, which is equals to, whose value is equals to, similar to A cross B plus A cross C. Then we say that it is distributive, it obeys the distributive property. Okay, is the distributive property. Now what is the next topic? Is making multiplication easier. How we can make multiplication easier? Means by using these laws. What are those laws? By using commutative, associative, distributive properties, we can do multiplication very easier. Okay, the way we make easier using this law is called multiplication made easier. Okay, now here multiplication of this, here we multiplied this in two ways. In the first way, what we have to, what would we have? Minus 25 into 37 into 5. In the first way, what we have to, we have multiplied 4 and 37. Here what we have to, minus 25 into 4 into 37 and minus 24 into minus 25 into 4. What we have to in this way? We multiplied these two at a time, and next this time this will gives minus 100 into 37. We will get minus 3700. But we will multiply this in a different way. Here 27 minus 27 into 37 into 4. What we have done? We have multiplied 25 and 37 first, and we will get 924, and we multiplied this with 4. We will get minus 3750. But which one is easier? Basically this one is easier because multiplication with 100 is very easy, you know. So wow, so we have to make multiplications easy. We can use commutative, associative, distributive properties while multiplications. Okay, here also 16 into 12 can be written as 16 plus 10 into 2, which is nothing but the distributive property, so that you can multiply easily. In that way, we can do all these problems. So finally, we have completed 5 topics. Now we have entered in the 6th topic, which is division of integers. How we will division integers? Basically, until now we have studied how we will multiply integers. Now, basically, what is the, in case of multiplication, 3 into 5 gives rise to 15. At the same time, if we divide 15 with 5, we get 3. So 15 divided by 5 is equal to 3. And 15 by 3 is equal to, and 15 by 3 is equal to, 15 by 3 is equal to 5. This is called a division. Okay, similarly 4 into 3 is equal to 12, but at the same time 12 by 4 equal to 3, 12 by 3 equal to 4. We can say for each multiplication statement of whole numbers, there are 2 division statements. Okay, finally what we can conclude, this is the multiplication statement. What it is? Multiplication statement. Multiplication statement is the multiplication. For each multiplicative statement, we can get 2 division statements. This is division statement, this is also division statement. Okay, 3 into 5 gives us to 15. From this, what we can do? We can do like this: 15 by 5 is equal to 3, and here 15 by 3 is equal to 5. From this only we got the 15. We take the 3 to this side, 15 by 3, that is equal to 5. But here we take 5 this side, 15 by 5 equal to 3. Here there are the multiply statements, and here are the corresponding division statements. Here minus 2 into minus 6 is equal to minus 12. How can we write it? Is minus 12 by minus 16, that is equal to 2. Minus 16, 12 by minus 16, that is equal to 2. And another way is minus 12 by 2, that is equal to minus 6. Minus 12 by 2, that is equal to minus 6. In this way, we can get division statements. Just in first case, we will take one integer or one number on the left side onto the right side to divide, and the second case we will take the remaining one to the right side in the denominator to get divided. These are, in this way, you will get 2 division statements. Okay. We observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before coefficient. What happens means, if you have to divide negative integer with positive integer, okay, this is called negative, or I will write clearly, negative integer with positive integer, what is the resultant? The resultant is negative. We have to put the negative symbol, and what we have to do, we have to divide these two as taking those two integers as whole numbers. Just the division which we done in the whole numbers is same repeated here also in the integers. Suppose for example here we have to divide minus 12 by 2. Here there is a negative integer, here is a positive integer. What we have to do, we have to put the negative integer before, and next what we have to do, we have to take these two as whole numbers and divide them treating them as whole numbers. Then if you treat them as whole numbers 12 by 2, then what happens, we will get 6. So the answer is 6. We'll write it here after the minus sign. So in division, when you divide a negative integer with positive integer, we will get negative sign. And so we can say that whenever we divide a positive integer by a negative integer, now here in this case we multiply negative integer by positive integer. In this case divide positive integer by negative integer. So what is the resultant? Positive integer by negative integer, we first divide them as a whole numbers. Here we have to divide them as a whole numbers and then put a minus symbol, that is negative. Again negative. What we have to do, suppose we have to multiply 72 divided by minus 8. Okay, 72 divided by minus 8. What you have to do, here positive number, here negative integer, so you have to put minus symbol, and treating 72 by 8 as whole numbers, you have to do the whole number multiplication so that you get 9. So this is the answer, which is negative. So in division, if you have negative integer on any of the numerator or denominator, will get negative. So a divided by minus b or minus a divided by b gives rise to negative only, and a divided by minus b and minus b divided by a divided by b are both equal. Next, what we have done, we have completed 6 topics. We have entered into the 7th topic, which is nothing but properties. Properties of division of integers. What are the properties? Here basically this is the statement. Okay, minus 8 divided by minus 4. So minus 8 minus 4 are negative integers. Dividing with we get 2, which is also an integer. So these two are separately integers, and after doing operation also we are getting an integer. So closure is satisfied. We can think closure is satisfied in this regarding this example. But when you multiply this minus 4 with minus 8, you will get minus 4 by minus 8, that is equal to, when we calculate minus and minus 4 by 2, we will get 1 by 2. The result is 1 by 2, which is not an integer. So finally what we have concluded, in some cases we are getting integer, in some cases we are not getting integer. So closure is not accepted. Closure property is not accepted in the division of integers, in the case of division of integers. So by doing so you can verify it. Okay, like whole numbers, any integer divided by 0 is meaningless. Like whole numbers, if any integer divided by 0, that is meaningless, and 0 divided by an integer other than 0 is equal to 0. So for any integer a divided by 0 is not defined. A divided by 0 is not defined. But 0 divided by a is equal to 0. Okay, next, finally, if you divided a by 1, the answer is 1. If you divide 1 by a, the answer will be another. So a divided by is nothing but 1. Sorry, a divided by 1 is a. So this shows that negative integer divided by 1 gives the same negative integer. So any integer divided by 1 gives the same integer. Any integer divided by 1 gives rise the same integer, like a divided by 1 equal to a. So finally what happened? Our chapter completed, students. We have completed our chapter. If you want all exercise problems to be solved, so if you want that, please mention it in the comment section. Now we will having some summary. We'll go to we are having some summary of whole chapter. Okay, without wasting time, we will complete the summary also. Okay, now what is the chapter name? That is the integers. It is having 7 topics. The first topic is nothing but the introduction. In this introduction, what we have recalled means, basically in the classic we have learned about whole numbers and integers, addition of integers and subtraction of integers. That we have recalled in this chapter. And the properties of the properties under addition and subtraction are we are going to discuss in this chapter. And second topic is nothing but recalling, how we are representing the integers on, how we have represented integers on a number line, how we have represented addition of integers and subtraction of integers on number line. All those we have recalled here. Basically, if you add a positive integer on a number line, then it will move to the right. If you add a negative integer on a number line, then it will move to left. If you subtract a positive integer number line, it will move to left. If you subtract a negative integer, it will move to right. After that, we entered into the third topic. Third topic is properties of addition and subtraction of integers. What happened when integers are added and subtracted, and what are the properties? The properties here are closure property. What the property says? Closure property under addition of integers. If you take two integers and if you add those two integers, then the result must also be integer. Then only the closure properties satisfied, or the integers are closed under addition. Basically, if you take two integers and if you add both those integers, you will get surely get an integer. So closure property is satisfied under addition. Then closure property and subtraction. What happened in this case also? If you take two integers and if you subtract those two integers, then you will get some result. That some result is also must be integer. Then only closure property is satisfied under subtraction. So in this case also, here a plus, if you take a and b, then a plus b also integer. We have get it. So closure is satisfied. In this case also you have taken a minus b, and in this case also a minus b is also an integer. A minus b also integer. So that is also satisfied. Next, commutative property. If you interchange the digits also, then if you get the same answer, then we say that it is the obeys commutative. 3 plus 5, here the two integers, when we interchange those also, we will get the same answer. So a plus b equal to b plus a. So commutative is satisfied. Again, now is associative property. What is the associative property? If you want to add three numbers, or if you want to subtract three numbers, by adding those, if you consider two integers at a time and one integer in another time, in the next case, if you change the brackets, and on that case also, if you get the same answer, then we will say that it is associative. In letters, in words, a plus b plus c, here we taken b plus c at a time, but here we taken a plus b at a time, but in both cases the answer is same. So we call it as associative property satisfied under addition. Now additive identity is nothing but when you add anything to an integer, if you get that integer, then we call the integer which is helpful to add, it is called the additive identity. So here 0, when added to any integer, we will get that integer. So 0 is called additive identity. A plus 0 equal to 0, 0 plus a equal to a. Then multiplication of integers. How we will multiply integers? When you want to multiply positive integer with a negative integer, what you have to do? You have to put the negative sign, and after that you have to treat those two integers as a whole number multiplication, and do normally what we do in the case of multiplication of whole numbers, and write the result. But one thing you have to remember is you have to put the negative sign. And when you multiply two negative integers, what happened? When you multiply two negative integers, the resultant is the positive integer, and you have to multiply both those as the whole like of whole numbers. When we multiply more than three or more negative integers, what is the resultant means? If the number of integers in the product is even, then the result is positive. If the number of integers in the resultant is odd, then the result is negative integer. Then properties of multiplication of integers. What are the properties when we multiply integers? Basically, first started with the closure property. If you take two integers and you multiply two integers, you will get then surely getting an integer. So a cross b is also integer. So that's why closure property is satisfied under multiplication. Next, commutative property. Commutative property is nothing but when you interchange the digits also, you have to get the same answer. Basically, when you multiply these two integers, you are getting that answer. When you rechange or interchange the digits and do the multiplication also, then also you are getting the same answer. So A cross B equal to B cross A here. Basically here A cross B equal to B cross A. So what happened? Commutative is satisfied under multiplication. Now multiplication by 0. What happened when you multiplied with 0? When you multiplied with 0, the answer is 0. So if your answer is 0. What happened when you multiply with 1? When you multiply with 1, you are getting the same digit, or we are getting the same integer. So we called 1 as the multiplicative identity. 1 as the multiplicative identity for integers and 0 as the additive identity for integers. After that, associative property for multiplications. What is the associative property? You have to take two when the case of multiplying three integers, if you take two integers at a time, and the next time if you take another two integers at a time, but the result must be same. Example are A cross B cross C. Here A B is taken at a time and you have done the multiplication. And next, A cross B cross C. Here you have taken B cross C at a time and you have performed the multiplication. But in both cases, you will get the same answer. So what we will finally tell that associative is accepted under multiplication. Then what? Distributive property. What this property tells that? What this property tells us? A cross B plus C equal to A cross B plus A cross C. If the LHS and RHS has the same values, then we say that those integers are supports distributive property. Next, the sixth topic is division of integers. How we will divide integers. For every multiplicative statement, we will get two division statements. 3 into 5 equal to 15 is a multiplicative statement. For that, we are getting two division statements like this. Okay. What we have to do when we are going to multiply a negative integer, divide a negative integer with a positive integer, you have to put negative sign and you have to divide them treating as whole numbers. And what happened when a positive integer is multiplied by a negative integer? You have to put negative sign and you have to treat them as whole numbers, and you have to do whole number division like that. Next, the seventh topic is properties of division of integers. What are the properties when we divide integers? Basically, on division of integers, we didn't support any properties. Even closure property also failed. Why? Because if you divide two integers, in some cases we are getting an integer, but in some cases we are not getting an integer. So that why closure property is also failed. And anything divided by 0 is not defined, and 0 by anything is 0. Okay, and if you divide anything with 1, we will get anything. These are the ones you have to remember while studying properties of division of integers. So what we have completed? We have completed our chapter and we have completed our summary also. If you can't understand anything, any concept, please feel free to comment below. And for exercises also, please feel free to comment below. And if you like this video, please like and share with your friends. Don't forget to subscribe. Sreenath. Have a nice day. Keep learning. Bye bye.